In this unit, we're solving quadratic equations. The first thing I want to introduce is the zero factor theorem, which tells us if you have a times b equals 0, then either a equals 0 or b equals 0. So basically, the only way to get 0 out is for one of those factors to be 0, because 0 times anything is 0. Okay, so that's one concept we're going to use in order to solve a quadratic equation. Let's move on to the steps for solving a quadratic. Step 1, set the equation equal to 0 first. Let's look at our example we have here. We have solve 6x squared plus 29x plus 35 equals 0. Does it meet that first requirement? Is it equal to 0? Yes. So we've done step 1, or the problem's kind of done it for us. Step 2 is to put it in descending order of powers of x. So again, descending order is highest exponent on the variable on down. And so we have that already because we have the x squared first, then the x, and then the constant. So we're good there. Step 3 says factor, and that's the big word with all of these problems. Factor the left side, including factoring out the GCF if needed first. If we look across all of these terms, there are no numbers or factors in common, and so we're good with factoring out the GCF. There's nothing that has to be done there, but we do have a trinomial on the left side, and so we want to go through the process of factoring for that. Again, the process that I use is factoring by grouping, and we want to get to 4 terms, and in order to get to 4 terms, we are breaking down that middle term into 2 different terms, and we have to do some work to get there. So let's set up our problem in the way we want it first, and that is keeping our outside terms. So we're going to keep our 6x squared and our 35, and we're going to put 2 blanks here, and we'll figure out what goes there. We also want to bring down the equal 0. Okay, so in our previous problems, we were factoring. Now we're actually solving an equation. So we're going to continue to bring this equal sign down, and we'll tackle that later. So on the left-hand side, we're going to come over to the side and figure out what goes in the blanks. So we have, remember, we have our a is the number in front of x squared. In this case, that's 6. B is the number in front of x. In this case, that's 29. And C is the number in basically the constant. And in that case, it is 35. Okay. All right. Our next step is to come to the side and do A times C. So A times C in this problem is 6 times 35. So let's calculate that. 6 times 35 is going to give me 210. It's a pretty large number for us to be working with, but that's okay. We can figure this out. Remember, we're thinking to ourselves what multiplies to A times C, again in this problem it's 210, and adds to B. B in this problem is 29. That's our question. And in order to figure this out, we are going to take our A times C, that 210, and list all the possibilities of what times what gives us 210, or what are our factors that will result in 210, and then we're trying to figure out which of those adds to B. So first, I would list all the factors of 210. I don't think 1 and 210 are going to work, but again, I'm very methodical about this, so we can go ahead and write that. We're going to start out with 1. 210 divided by 1 is 210. Go to 2. 210 divided by 2 is 105. Check out 3. 210 divided by 3. That works and gives us 70. Let's look at 4. 210 divided by 4 is 52.5. So because it's a decimal, I'm not writing that one. Let's do 210 divided by 5. That works out to give 5 and 42. 210 divided by 6 is 35. 210 divided by 7 is 30. We're getting closer, so you're always you're kind of doing this little check every time. You're like, okay, does this add to 29? Well, we're not there yet, but we're getting closer. Let's move this up a little bit so I can see. Okay. And then let's do 210 divided by, so that was 7. Let's try 8. 8 gives us a decimal, so 8's not going to work. Let's do 210 divided by 9. That's a decimal. 210 divided by 10 is 21. That gives us 31. We're getting closer. 210 divided by 11 doesn't work. 210 divided by 12 doesn't work. 210 divided by 13 is 16 point something. That doesn't work. 210 divided by 14 gives us 15. And I know, students will be like, oh my gosh, how do you get that? Okay, well, obviously with things like this, I've got to go through the process too. There are some things, like if that number was 10, obviously that's easier to deal with. But even with big numbers, we have to go through that. Okay, all right. What would you do at this point? If I was to keep going in this list, I would get 15 times 14. That would be a repeat, and that isn't how you would know to stop if you're not checking along the way, which is fine, okay? But now we need to actually do the second part of this. So we figured out all the numbers that multiply to 210. Now we need to figure out what combination adds to 29. And so if you start adding these together, I'm not going to write all of this out, but 1 plus 210 is not going to give me 29. Let's skip a little bit. 5 plus 42, that's not going to give me 29. So as you do that, you're going to see that 14 plus 15, that does equal 29. So we've got our multiply, we've got our add, and 14 and 15 are going to be the numbers in the blanks. Okay, so remember, this is taking that 29x that's in the middle there, splitting it into two terms, 14x and 15x. And we now want to put our little plus signs there so we know what the sign is and we know both of these are positive. Remember though, you don't get to choose the numbers, as in you don't get to randomly pick. It does matter, and that's what this whole A times C process is. Okay? All right, from there, we're going to group the first two and group the second two. In the first group, you're figuring out what is our greatest common factor. And so our greatest common factor here, 6 does not divide evenly into 14. So remember, greatest common factor, you look at the smallest number and it's either that number or smaller. So if 6 doesn't work, what's a smaller factor out of 6? Well, 3 times 2 gives us 6. So let's try 3. Does 14 divided by 3 give us a whole number? No. So let's try 2. Does 14 divided by 2 give us a whole number? Yes. Okay, so that's your thought process as you're working through this. Clearly, both of these are even, so 2 is going to be part of our GCF. And so remember, whatever you think is your GCF, or whatever you choose as your GCF, that's what you're putting out front. But don't just do the number. You've got to consider the variable as well. So we've got x squared and x. X is going to be in common because there's an x in both of those terms. Once you figure out your GCF, you need to divide both of these terms by whatever you put out front. Okay, so 2x in this case. And we're going to open up and do this division to figure out what goes in this factor. So 6 divided by 2 is 3. X squared divided by x is x. You should always have an x in this inside this parentheses. Plus 14 divided by 2 is 7, and x divided by x cancels. So that's that one. Let's look at our second group. We have 15 x squared plus 35. So does 15 go into 35? You can take your calculator. 35 divided by 15, is that a whole number? No. Let's break 15 down. We've got 5 and 3. Take 5. Always start with like the highest number and check it. So does 35 divided by 5 work? As in give you a whole number? Yes. So 5 is going to be our GCF. You are not putting an x here because there's not an x in both of these terms. So the number would only be the GCF for this, for this one. That said, let's take this 5 and divide both of these terms by it. And then we're going to do that division to figure out what goes in this factor. So 15x divided by 5 is 3, bring down the x, plus 35 divided by 5 is 7. And how do you know you're on the right track? Well, these two parentheses should match. Okay, and they do, so we're headed on the right track. Now, again, this is an equation, so I need you to bring down the equal 0 there. Now, our next step is to write this as our two factors. So we're going to write this as 2x plus 5 and then 3x plus 7 equals 0. Where are those coming from? That's coming from GCF here is creating our first factor, and then our common parentheses created our second. And if I said just factor, this is where we would stop. But this only got us to step 3, and that's okay, but let's keep going with our steps. So we have now fully factored on the left-hand side. Step 4 says, set each factor containing a variable equal to 0. So we've got our two factors, that's each of these parentheses here. We're going to set each one of those equal to 0 and basically separating it into two separate linear equations or two separate problems. So this is going to be 2x plus 5 equals 0 and 3x plus 7 equals 0. From here, these are linear equations that now we're going to solve. So we're going to subtract 5 here. That gives me 2x equals -5 and divide by 2. And one of my answers is going to be that -5/2. Let's do the same thing on the right-hand side. So subtract 7. 3x equals -7 and divide by 3. And -7/3 is my other answer there. So remember that, kind of like some of our previous problems that we talked about when we had an x squared in the problem, when we use square root property, you're going to get two answers. Order does not matter here, so whatever you want to do, if you end up with factors in the opposite order, that's fine. You just are writing these answers in a list. So you have two answers with a comma in between, but no parentheses, because this is not an ordered pair. You're not graphing or anything like that. So our two answers would be -5/2 and -7/3 for this. And again, answers are solutions, okay? So this is an equation. So the answers we're getting out here are the solutions to the equations. Let's try one more. This one was fairly simple in the terms of we have both positive signs, but let's try one where it's not both positive, okay? So our next problem is x squared minus 4x equals 21. Okay, so looking back at our steps, you can, hopefully you wrote those down or you have notes that you can go by. So step 1 was get it equal to 0. So is this equal 0? In this case, no. So we're going to move the 21 over using the same rules that we would do for linear equations. So changing the sign here. Okay, so that's going to be x squared. And when we write this, we're writing in descending order. Don't try to put the 4x and the 21 together. We want to write this in order of x squared first, then the x term, so minus 4x, then the constant, minus 21. And that's going to equal 0 because 21 minus 21 equals 0. And this was our goal of that step. So we've also taken care of the descending order. That was step 2. Step 3 is factor. So we want to factor on our left-hand side here. That means we're going to first set this up. So x squared with a blank and a minus 21 equals 0. We're breaking down the -4x, but we don't know what that's going to break into yet. So let's figure that out. What is a in this problem? Think about it. Okay, remember this is an understood one. So a in this problem is going to be 1. C in this problem is -21. So A times C is 1 times -21, which is -21. Okay? Now, what's our sentence we're saying to ourselves? We're saying what multiplies to -21 and adds to B. B in this problem is, again, we're looking here, not at the problem itself. We want to look at it where it's equal 0. So our B here is -4. Okay, so how do we figure this out? we're going to first take our 21. Forget the sign for a minute. We'll come back to that. Let's list all of our factors of 21. So 21 is 1 in 21. 2 doesn't go into 21. 3 goes into 21 7 times. 4, 5, 6. Now we're back at 7. 7 times 3 is 21. So really these are our only two pairs of factors. From here, we're trying to figure out what adds to negative 4. What adds to negative 4. However, again, add could really mean subtract, okay? Because the signs are what you have to figure out. We have a negative number that we're multiplying by. So if you have a negative, or that you're trying to get, if you have a negative and you've got two factors multiplied together, that means one factor is negative and one factor is positive. So the signs are opposite. They're different. Okay? How do you know which is which? That's where B comes in. So B, the sign of B, goes to the bigger factor. The bigger factor. So looking at our numbers, 3 and 7. B is negative. Our bigger factor is 7. It's going to get the negative. And if you don't remember these rules, that's totally fine. Just try the signs out. You only have 4 options. Both positive, both negative, one negative, one positive, one positive, one negative. Okay, so how do you check to make sure you chose the right version? You're going to do the add. So 3 plus negative 7 is negative 4, and that's that negative 4 we're looking for here. Okay, if you ended up with a positive 4, you have your negative sign on the wrong one. All right, so 3 and negative 7. I like the little trick of if the signs are different, I want you to put the negative one first. That makes life a little bit easier when we go and do grouping. You don't have to, and it'll work out the same either way. But let's do negative 7x, don't forget the x there, plus 3x. Now we have 4 terms on the left, and we're doing grouping. So we're going to group the first 2 and group the second 2. In the first group, we have an x in common. We have no number in common between 1 and 7 other than just 1. So we're taking our x out and we're dividing by x for both of these to figure out what goes in the parentheses. So x squared divided by x is x minus 7, x is canceled, plus 3x minus 21. What do we have in common there? Well, 3 goes into 21, so 3 is our GCF. And we're going to divide by 3. So this is going to be x minus 7 equals 0. Now we're rewriting our factors into our factored form here. So again, we've got x plus 3, and our common factor is the same, which is what we want. And we're going to write that second as x minus 7 and set equal to 0. And then from here, set each one of these equal to 0. This is our new step. And solve. So subtract 3 and you get x equals negative 3. Add 7 and you get x equals 7. So our two answers, in whatever order you want, is negative 3 and 7. Okay, and again, these are solutions. These are the solutions to the equation. All right, lastly, I want to look at a couple different ones that are just a little bit different because they don't start the same way. So if we're going through our steps, step 1 said, make sure it's set equal to 0. Okay, well, both of these are. Step 2 said, put in descending order. But then it also said, if it's factored, skip, and go down to setting it straight equal to 0. Okay? And so we get lucky on these two because both of these are already in factored form. How do we know that? Because look at them. They both have sets of parentheses that kind of denote that this is in factored form. If it's in factored form, you don't have to go through all that factoring by grouping. You're pretty much almost to the answer here. So the important thing about the steps is it says set each factor containing a variable equal to 0. So if it does not contain a variable, then we're not going to consider that because you have no variable to set equal to anything. So a perfect example of this is this first example here. You've got 5 times x minus 2 times x minus 3. So our only factors containing a variable are the x minus 2 and the x minus 3, or x plus 3. So what about this 5? Well, the 5 you really can ignore, but I want you to understand why. Because technically, if I wanted to kind of consider this 5, I could actually divide by 5 on this side and divide by 5 on this side. What would that do? 5 divided by 5 is 1, so that it didn't really change anything on the left-hand side. I still just have x minus 2 and x plus 3 equals, what's 0 divided by 5? Well, that's still 0. So because you just have a number sitting there, you can kind of ignore it. Now, if there was an x with it, like in the second example, you do have to consider that differently, and we'll talk about that in a second. But here, you already have this already factored, so you're going straight to setting this equal to 0 and solving. The other thing I want you to get in the habit of understanding is that if I have a factor x minus 2, okay, no number in front of x, let's just look at this one. To solve this, all you're doing is changing the sign. Okay, so if I move the 2 over, I'm changing the sign to do so, and I'm going to get 2. So you could technically, I want you to start understanding this, go from x minus 2 to 2, okay, and that's fine. I want you to understand that all you're doing is setting it equals 0, changing the sign. So if we did that, what would our answer be for x plus 3? If we have plus 3, to move it over, you're doing minus 3. So my answer here would just be negative 3 when I solve that right side. So my two answers would be 2 and negative 3. Okay, so I want you to get in the habit of doing that. It does get a little more complicated when there is a number in front of x, but you're going to use this pattern a lot in this class. Let's consider our second example here. This one is a little different. Why? Because we have an x out front with the number. So we've already got it factored. It's already set equal to 0. But I have to consider every factor containing a variable and set that equal to 0. So this one contains a variable. Let's set that equal to 0. So 3x equals 0. That's one of our answers. We'll figure that out in a second. Let's do the same thing for our other two. So this is going to be x minus 1 equals 0. 2x minus 5 equals 0. Solve, solve, solve. Okay, so here we're going to divide by 3. That's going to give us x equals 0. Can you have 0 as an answer? Absolutely. 0 can be an answer. This is really important. I want you to know this. You're going to see this again in this class. Okay, plus 1. Again, we could do the same thing that we did in our previous problem, just change the sign. And this one, you got to do a little bit more work. So plus 5, 2x equals 5, divide by 2. Really, all you're doing is changing the sign and dividing by the number in front. So we actually get 3 answers here: 0, 1, and 5/2. What I see students do is they forget the 0. So don't forget, that's important. In our previous factoring, you even had to take out an x first. It started out with an x cubed, right? And there was an x in common with all of them. You had to take an x out first. And I always said, don't forget it. Bring it down because it's important. Here's why we're seeing this, because it contributes an additional solution to our equations. Okay. Lastly, I just want to say real quick on this one, all 3 of the previous ones that I did were quadratic. If you multiplied x times x here, you would get x squared. Okay. However, this one that I just did is actually not. This is a cubic. This is a cubic equation. Cubic is when you have x cubed. You just can't see the x cubed because you have it already factored. But if I was to multiply this 3x times this x times 2x, that would give me 6x cubed. And if I multiplied all this out, which I don't want you to do, but you would see that this is an x cubed, and that would tell you you can get up to 3 answers on this. So this one is a little kind of separate from the quadratics that we've done, but still very important. And you need to understand that every single term or factor that has an x, you've got to set equal to 0.